morning, Radar Elementary kids. Mr. Serpico checking in. Hope you had a great week of virtual learning. Today we're going to do a lesson, lesson 14.4. We're going to be looking at three-dimensional shapes and calculating surface area. So we've been talking about nets and we've been talking about 3D prisms. So for today, I like to think about surface area as if you had to paint the outside of a 3D object, how much paint would you need to cover that space? If you're wrapping a present and you have to cover the entire outside with paper, exactly how many square inches of paper would you need? Square inches or square centimeters, whatever your unit of measurement is. So I'm going to use some images from my friend Mr. Goldstein over at Wayne. We've been sharing some resources back and forth. So I'm going to be using some images from his smartboard file to communicate this lesson objective. The surface area of a prism by adding the areas of all the faces. So what that means is if you think of a box, you think of a tissue box, if you will, and you figure out the base and height of that tissue box for one face of that rectangle. Let's say it's 6 inches by 3 inches. You know that the surface area of that side of the tissue box, is 6 times 3, base times height, is 18 inches, right? So there are 4 sides of that tissue box that are 18. So you would simply add 18 or multiply 18 times 4. And then you would have to figure out the surface area of the other 2 faces. So this next slide here gives you a better visual for finding the surface area of a cube. And in this case, it's not a cube. It looks more like a rectangular prism with having 4 rectangle sides and then 2 sides at the end that are squares. So you see that side is a square, that side is a rectangle. This side here would be more of a square. So you're going to find the area of each face of this rectangle and then add them together. When you look at this example, again, a cube is made of cardboard and has edges measuring 4 centimeters each. This is a little bit more of a true example of finding surface area of a cube. Let me pull this down so you can see better. A box cut along the dotted lines and laid out flat. The flattened figure is actually a net of a cube. We talked about that a little bit yesterday and the day before in some of the previous examples. If you take a box and you were to break it at the different folding points, you could actually unfold a box into the shape of a net. So the figure 4x4 cube is the same exact figure as the one you see below. She's saying you can now see the 6 square faces of the cube. And the young man is saying, what is the shore AR of a cube? It should say area. It looks like there's a typo there. So let's take a look at the net of the cube. And you've got 6 faces, right? And then each face is 4 inches by 4 inches. So if you multiply to find the area of one of those square faces of the cube, you've got 16 centimeters squared. 16 centimeters square is the area of each one of these squares. Now I know the figure is a little distorted. They look more like rectangles, but that's just when you stretch it out on a smartboard file, sometimes the scale is not right. So you found out that the area of each square is 16, and there are 6 faces. So there's 2 ways you can do this. You can just add up your 16s, or you can multiply 16 times the 6 faces And in that case, you would get 96 centimeters squared. So that's essentially what you're going to be doing in these problems. You're going to be finding the area of each face, and then if it's something like a cube, you could just multiply that by the number of faces, right? As it is in this other guided learning practice here. You've got the cube, you've made it into a net. You could find the area of each face of this cube and then multiply that once again. Because each face is congruent, you would multiply that by 1, 2, 3, 4, 5, 6. 6 faces. Okay, six squares at 5 by 5 each. So take a minute to try to solve this on your own. You want to pause the video right here and try to figure that out. And when you're ready, you can unpause, come back together, and we will go over the answer. So you probably figured out 5 times 5 is 25. So 25 square inches for each square. And then there are 6 faces. So if you do 25 times the 6 faces, you got your answer. You get your answer of 150 inches squared for the cube as a whole. So let's take a look at this figure here. It says find the surface area of a rectangular prism. So it's going to be a little bit more complex because not every dimension in a rectangular prism is exactly the same, such as it was in the last couple examples with the square. You've got a 10-inch base, you've got a 6-inch width, and a 5-inch height. So what you need to do here is you need to find out the area of each face of this prism. So what would that be? What would that look like? What kind of math would that be? Might be a good time to stop and try that again. But you're probably thinking, base times height. So you're doing 5 times 6 or 6 times 5 rather for that face of the rectangular prism. And then another face would be what? 10 times the height of 5, right? So in this view here, what do we make? Well, you probably said a net, right? And what we've got for you to help you visualize it at this stage of the game is you've got color-coded shapes to help you visualize which shapes are congruent. So in this approach, this is really smart if you're doing it in your workbook. You just find the area of each one of these shapes. Feel free to even color it. And then you could use multiplication and addition to find the total surface area. So the first blue figure is 5 times 10 is 50. The green area, the height of the rectangle, of the rectangular prism, is 5 times 6, right? The base times the height. So the width of the base was 6 times 5 is 30. And then the center area would be 6 times 10. Your base times your height. 6 times 10 is 60. So all of these are in square inches. You could use order of operations and you could build out using PEMDAS and parentheses, you can build out what this equation would look like. And there are, again, a couple of different ways of doing that. But you could see area of 2 of the brown rectangles, they look kind of red on my screen, would be the 60, right? So 2 groups of 60. And then the area of the 2 greens would be 2 groups of 30. The area of the 2 blues would be 2 groups of 50. So then you get those totals: 100 for the blue, 60 for the green, and for the red area, and you add them together, and you get the total area for the whole prism. Now here's another one. I'm going to stop it right here, and I'm going to let you guys try to start to figure out some of these problems in your workbook. I suggest you guys start and try to tackle page 197 and 198. 197, 198 would be the 2 pages to start to practice on your own. I don't want to make this video too long.